Hello, Sauce here. This is a video lesson relating position and velocity. We're going to do that by making some simple graphs. I'm making a graph of a line starting at the origin, going straight to a point on the horizontal axis. We will make a tick mark and call it 18. The horizontal axis will be our time axis in seconds. And this point, we'll make a tick mark on the vertical axis and label it 90. We'll call it feet. And this is a position graph as a function of time. So we can see in this simple situation that we have at time 0, we begin, and as time moves on, we go up, our position changes, and at time 18 seconds after start, we're at 90 feet. We're going to relate that to a corresponding velocity graph. And the velocity graph, the horizontal axis, will be the same interval, same measure. We have a tick mark at 18 seconds, and we're going to graph velocity as a function of time. But before we do, let's think about the equation that physics gives us that relates velocity, distance, and time. Velocity is equal to change in distance over change in time, or V equals d over t. This equation here has a d in it for distance, but what I've graphed here on the vertical axis is position. What's the difference between those two terms? Well, it's very similar to speed and velocity. When we use the word distance, we're usually concerned with the overall magnitude. We don't care whether it's positive or negative. If you are before the starting point, you can think of it as having a negative position. But the distance would just be the magnitude of the distance between your position and the starting point. Position, like velocity, is a concept that carries sign, meaning we care whether it's positive or negative. It implies, when you use position, that if you have a positive position, then you are before or after or above a starting point. And if you have a negative position, you are behind or backwards or below a starting point. So this equation here, we could write it as velocity is equal to position over time, but here I'm writing it in the familiar physics presentation. We could also write this as velocity is equal to delta d over delta t. Includes the concept of change in. Now, it's the same equation, but we're reminding ourselves that, for instance, at time 18 seconds, we can think of that as a change in time from the initial 0. So when we get to 18, we've changed time by 18 seconds. Or we could just think of it as the magnitude 18. Either way we go, when we include the deltas in here, we're reminded that this is a slope calculation. Velocity is a slope calculation. Rise over run. In this case, the rise is a change in distance or position, and the run is a change in time. If I was to calculate the slope of this line, I would think of it as a rise of 90 over a run of 18. And this velocity then is the change in position of 90 divided by the change in time of 18, which can be reduced to 5. And if we include the units, then it is 5 feet per second, which is a velocity. And if I'm going to graph this velocity, then I would label the axis 5 and give it a constant 5 feet per second to reflect that the rate of change in position is constant. It's the slope of this line, and the slope of this line is always the same no matter where you are on it. So we have a constant velocity. Let's give another example. We'll make this one a little bit more complicated. I'm going to draw a graph where the vertical axis is position as a function of time. And the horizontal axis again is time. And we'll make some tick marks. We're going to graph a constant piece at 20, and then a linear piece that goes down, another constant piece here, and the linear piece that goes up. This is a position graph, and it's going to relate to a velocity graph that has the same intervals on the time axis. Let's label these 8. If we're going to graph the velocity, then we can think of it, velocity is the slope of position. The position here is going to have different slopes depending on what piece we're at. So the velocity is going to be different at different intervals. The velocity from 0 to 2 is the slope of the piece of the position function. This linear piece has a 0 slope. Position is not changing. Over the first 2 seconds, we could say the position remained 20 and did not change. So the change in position is 0 to reflect that no change in position. The change in position on the interval from 2 to 4, it's negative because we start at a positive 20 and go down to 0. We can calculate the slope of this linear piece on this interval. We have a rise that's negative, we go down 20, and a run of 2. So that would be negative 20 over 2 or negative 10. And the velocity then on that interval is a negative 10. If the units were feet per second, then this would be a negative 10 feet per second. On the interval from 4 to 6, we again have a 0 velocity to reflect the 0 slope, no change in position on that interval. On this last piece, we have a rise of 10 positive and a run of 2. 10 over 2 reduces to 5 over 1, and the velocity is positive because we're rising at a rate of 5 feet per second on that interval.